Hello everyone, welcome to a new series of It's a Gray Matter with Kylie Jones. Hello? Why can't I use breaking news? Okay, broken news just sounds sad and fixing news sounds a little lame. I don't know. Yes, the research is a little old, but breaking news will work just fine. The research is current enough. Thank you. Okay, now we can get started. I'll be doing a news-themed segment on the enteric nervous system, or ENS, also known as the gut-brain system. Specifically, I'll be comparing its control condition to anxious, depressive, and anxious-depressive systems. The normal ENS will look green, the anxious will be orange-red, the depressive will be blue, and the anxious-depressive will be pink. From internal to external, each version is going to have a mucus layer, a submucosal nerve plexus, circular muscle, a myenteric nerve plexus, and a longitudinal muscle layer. I'm interested because the enteric nervous system is in the same group as the sympathetic and parasympathetic nervous system, which are involved in stress response, and theoretically would be involved with stress and mood disorders. So I'm comparing three key elements: cells unique to the enteric nervous system, neurochemicals, and bacteria that would be characteristic of the enteric nervous system. As I'm sure you've seen, I'll be using a crochet model for all of these, and the cells and bacteria will somewhat resemble scientific models. Any information will pop up in the bottom center of the screen in the form of a parenthetical citation. Here are the key players of the ENS. Meet the brain, the vagus nerve, the stomach, the intestine, and the colon. The intestine pops up in the most studies and will have the most focus. The stomach and colon only appear in 1 or 2 studies. The vagus nerve plays a large role in modulating the stress response along the hypothalamic pituitary adrenal axis and the resulting inflammation in thoracic and gut organs, such as the stomach and intestine. On to our control model of the ENS. Cue the music. Here we have the control ENS with cells, chemicals, and bacteria in place. We'll start with the cells, which won't change much across the 4 conditions, but would be good to know. First, we have the enteroendocrine cells, responsible for secreting neurohormones. Then we have the neuropods, which perform a similar function for glutamate, but synapse with the vagus nerve. We also see the tuft cells, which help synthesize acetylcholine, found here, and heal the mucosal layer of the gut. And here we have the enterochromatin cells, which release serotonin diffusely into the vicinity of the vagus nerve. Enteric glia and muscularis macrophages both enhance the immune system of the ENS. Enteric glia patrol the entire ENS, all 5 layers, while the muscularis macrophages monitor the myenteric plexus only. Again, these cells won't be discussed much in the other conditions due to little change in themselves, but they will pop up every now and then. Next, we'll take a look at the bacteria. Prevotella here looks like our regular weather forecasts. It is either low or absent in a healthy ENS. Escherichia is in the same situation, which is fitting given that it's related to E. coli. On the other hand, both Lactobacillus and Enterococcus are plentiful in a control ENS. Meanwhile, Bacteroides sits at a low level in the control ENS, as does Clostridium, but both are present. Finally, we'll touch on the cast of chemicals, which include neurotransmitters, hormones, and interleukins. First, we'll touch on the neurotransmitters. Classics like serotonin, dopamine, GABA, norepinephrine, and acetylcholine affect a person's mood. They also regulate the immune system in the gut-brain axis, particularly GABA and acetylcholine, and gastric movement and acid production, particularly, again, GABA and serotonin. Glutamate, the main excitatory neurotransmitter, comes from neuropod cells and excites the vagus nerve in a quick manner. While GABA and glutamate can't cross the blood-brain barrier, acetylcholine, dopamine, and serotonin precursors can. The gut-brain axis forms more than 50% of dopamine and serotonin precursors, so it wouldn't be much of a stretch to say that the gut-brain axis plays a role in mood and could have a relationship with mental conditions such as anxiety and depression. Meanwhile, gut peptides such as cholecystokinin come from the enteroendocrine cells and affect cytokines that then release neuropeptide Y, which acts on the vagus nerve and brain. The hypothalamus then releases a trigger known as corticotropin releasing factor and then triggers cortisol, our stress hormone, which happens in the normal ENS, but is emphasized in anxious and depressive conditions. In the brain, CCK activates the basolateral nucleus of the amygdala, which is going to be somewhere deep in the temporal lobe here, and the hippocampus, also in the temporal lobe, which can increase anxiety-like behavior. However, vagus nerve stimulation can weaken CCK's response, throwing it out of the picture. Oxytocin generally has an inverse relationship with stress. It's often released from the hypothalamus by norepinephrine and interleukin-1 beta. While oxytocin doesn't affect the gut-brain axis itself, lactobacillus in the ENS can still affect oxytocin. It affects its release and enhances social behavior in mice models. Meanwhile, cytokines interleukin-1 beta and interleukin-6 are part of the pro-inflammatory cytokines and are often active in general inflammation and anxious and depressive states. So, that's our cast. That's everyone in the studio. Well, everyone except the closet gremlin, who I'm sure we'll see soon enough. Thanks for watching, and tune in next time on It's a Gray Matter for more breaking news on the enteric nervous system. And live, absolutely breaking news, is the mess going on in the studio right now.